Hi everyone. In this short video, I'll introduce Prism, a simple data-free task-agnostic method to reduce spurious biases in vision language models like CLIP while maintaining overall accuracy. Vision language models align images and text in a shared space and work great for zero-shot tasks. But they also inherit dataset biases, like camel implying desert or panda implying bamboo. So models over-rely on background or context rather than true class features, hurting worst group performance. Prior approaches either need predefined bias categories, rely on external images, or degrade accuracy by removing semantic content. We wanted a way to remove spurious cues without extra data or task-specific labels, and still keep image text alignment. Prism has two stages. Stage 1 uses a large language model to propose spurious attributes and generate bias-aware scene descriptions from just the class names. Stage 2 learns a projection P, so the embedding in the new space reduces dependencies on those attributes. Then we do zero-shot classification after projection. In stage 1, given prompts like a photo of a class name, the LLM outputs common spurious attributes and scene descriptions that mix classes and attributes. This leverages the LLM's internal co-occurrence statistics to surface likely biases, no labeled image required. In stage 2, we learn P using our latent space debiasing loss. It has two parts. First, an intra-class inter-attribute term that pulls together embeddings of same class across different spurious attributes. Second, an interclass intra-attribute term that pushes apart embeddings that share the same attributes but belong to different classes by a margin. This contrastive structure builds class-relevant invariance while suppressing attribute shortcuts. We also introduce Prism Mini. Instead of learning P, we encode the bias attributes and apply a simple orthogonal projection to remove them from the space. It requires no optimization and is useful when compute is tight. We evaluate on Waterbird and llm-guided using zero-shot clip, reporting overall accuracy, worst group accuracy, and the gap between them, since lifting the worst group is the primary goal in debiasing. Here is the key takeaway. Prism reaches the best debiasing among data-free methods without sacrificing accuracy, pushing the worst group versus accuracy frontier forward on both datasets. Prism Mini lands second best among all data-free methods at a fraction of the compute. In numbers, on Waterbird, Prism achieves 84.2% worst group and 93.6% overall accuracy. On llm-guided, 84.0% worst group with 86.9% overall. State-of-the-art debiasing among data-free approaches, competitive even with the methods that use images. In the embedding space, clusters become more disentangled, indicating reduced reliance on background cues. We also find that text-only bias mirrors image bias, validating our llm-guided scene description are effective debiasing signals. In practice, Prism needs no labeled image, keeps clip frozen, and train the projection quickly. Then inference is just a single projection. Limitation includes reliance on the LLM's bias discovery quality and the linear nature of the projection, which may miss high nonlinear biases. To wrap up, Prism uses LLM-guided bias discovery and a contrastive LD loss to learn a projection that suppresses spurious cues while preserving semantics. It's data-free, task-agnostic, and effective. Thanks for watching. Details and codes are linked below.